Hi everyone, my name is Brie Moreau, and today I'm going to talk about not pretending that we know how to rank in LLMs. Because there's a lot of presentations around how to rank in LLMs and all these things, and you see these presentations where they take a photo from ChatGPT and then they say that they've magically figured everything out, and everything is far from the truth. And you'll see the amount of research that we've done to get to what we've got to, and you'll understand that a lot of people haven't actually done this amount of research. So who are we? Who am I? My name is Brie. I've been doing SEO for 18, 19 years now, and started getting into data science quite heavily about 3 years ago, understanding how to transition across to GEO. This is my team, and there's no way I could do any of this without this team, so I just want to say thank you to the team. And yeah, so basically we have over 100 link builders in the company and a team of data scientists, and that's what we specialize in. Specifically, data science with backlinking is the main things that we do. We're a US-based company. We deal with US-based clients mainly. And yeah. Oh, and your brain will be broken, as you can see up there. Yes, your brain will be broken. The point is, when your brain breaks, it's actually learning and neuroplasticity and all these things. And so if you're in meetings with me in the data science team, they'll explain these concepts to me and I'll go, can you explain that really, really slowly? And then I'll ask them again and then again. So this is quite normal to be overwhelmed on some level. So I'll try to find the fine line between overwhelming and giving you good information, if that makes any sense. So if we can just all be happy that that's what's going to happen, then yeah, set the expectations there. So this is one of our clients, 6 million monthly traffic. When you kind of hit these kinds of levels like that, when it plateaus out like that, it means you own position 1 for all the keyword terms. There's nowhere higher to go. If you can understand what 6 million monthly traffic could do for revenue for a US-based company, you can kind of understand why we have such a big team. Again, more of these kinds of things. That's 14 million a month, and it just keeps on going on. Some of them are lower, like 2 million, like 1.5, 1.6, but just depends on the keywords and how valuable the keywords are. Yeah, and it just keeps on going on. So the process that we've developed with backlinks, with data science, it's not exactly what I'm going to talk about today, but just understand that we really know what we're doing. It's probably the best way to say that. Keeps on going. And also when we build out new sites as well, we're able to kind of make them just blast really, really quickly as well. I'm not going to talk about the process that we did to achieve this. I'm going to talk about LLM optimization and our research in LLMs. So this is one of our main clients. So this is our main client. We took them from position 30 to number 1 in the world for online casino in less than a year at 1/10 of the budget of the competitors. We've generated billions of dollars in revenue for them. And so, yeah, and this is one of the hardest keywords in the world. So with the SEO side of it, we've been very, very successful, and we now have an R&D budget to basically deploy what we do for stake.com and other large companies as well. So what you're seeing in the presentation is over 1,000 hours of data science research with my team. Highly specialized. There's not many people like our team in the world, at least. Yeah, so this is the process. We end up building a machine learning algorithm, and that's how we pull off these results. Whether it's in online casino or other niches as well, the process works the same. We basically built reverse engineered Google search engine. So this is a live test. I want everyone to pull out their phone, and I want you to type in best hotel to stay in Hawaii. And then the objective here is to see whether you have in any of the results either the Four Seasons Resort or the Ritz-Carlton. So we're looking for Ritz-Carlton or Four Seasons Resort. So it's easier if I actually ask who doesn't have it. So who actually doesn't have Four Seasons or Ritz-Carlton? who doesn't have it? Ah, okay. It's normally like a small percentage of people don't have it as well, but that's normal as well. But you can see everyone else has it, right? Now, when we think about ChatGPT, so all this research is based on ChatGPT, but we're doing other research in Gemini and other things as well. But so everyone thinks that ChatGPT is like super personalized and this amazing tool. And the more research that we've done on ChatGPT, the more we realize that it's actually very, very broken. And everyone's kind of like, it's a bit of a honeymoon period right now. And a lot of you have probably seen the hallucination rate for ChatGPT is 35%. All right, it's crazy. It's crazy. There's actually like a hallucination ranking that ranks the models, and ChatGPT hallucinates a lot. Now, does anyone find that interesting that pretty much everyone in the room got Four Seasons and Ritz-Carlton? And how many of you have ever stayed in the Four Seasons or Ritz-Carlton before, right? And I'm going to explain to you why that's happening, okay? Because we reverse engineered everything, we figured out these patterns, and we're able to explain why these patterns are happening. The funny thing is, it is a bit personalized, because if you look at this result here, it says, Hotel Walia, more intimate, romantic, adults only vibe. So there is some personalization there. Apparently, that's what ChatGPT thinks about me. Now, oh, okay, that slide is not, it's because I've taken it from Google Slides. There's some amazing data for you to ponder over what that slide actually says, because I converted from Google Slides to PowerPoint just before. That's what happened. Average session duration normally for ChatGPT is around about 9 minutes, and for search, it's around 5 minutes. So people are spending a lot more time on ChatGPT and all the LLMs, and they're asking like very, very like transactional questions. It's like comparative kind of questions, and you'll see that when I was thinking, I was like, oh my God, I hope the rest of the images work, and they do. So the revenue is around 4 times as much. It's like not much traffic, but it converts a lot higher. And like I've just been, I've presented like this presentation to like over 1,000 people in the past couple of months, and had a lot of conversations with a lot of people. And some people have pretty much just like lost a lot of Google traffic and just like replaced it with ChatGPT traffic. Like it's very varied on what's actually happened. Now, really interesting, like if you think about it, if all of a sudden Four Seasons Resorts and Ritz-Carlton right now, they just got a whole bunch more bookings, right? A whole bunch more bookings, and they don't probably even know why. We know why, but they don't. And so you'll see this in probably other niches as well. Some people are just going to have a whole bunch of referral traffic from ChatGPT. Now, interestingly enough, it's really hard to track ChatGPT traffic, but in saying that, if you get a lot of brand searches and people are converting, because you'll often get as well, if you're not getting straight referral traffic from ChatGPT or LLMs, you'll get an increase in brand traffic that's converting. This is another way to see that it's actually coming from the LLMs. So basically, everyone thinks that like, oh, if you want to rank in the LLMs, just do really good SEO and you're going to rank in the LLMs. It's completely untrue. The overlap is 12%. Yeah. So I'm breaking a lot of realities that people have in this kind of space. It's 12% overlap. It's got nothing to do with Google, unfortunately. It does, however, have quite a bit to do with Bing. 20% overlap, obviously, because Microsoft is an investor in OpenAI. And yeah, if you want to read these studies too, this is someone I know, Josh, from Profound. Like, there's some good studies in there as well. I can share the slides with you later as well. But everything's got citations on it because, you may as well be able to check and do your own research. Now, this is really interesting. This is called sample poisoning. It's basically negative LLM attacks. So Anthropic decided to see how much work it would take to change the results in an LLM. And I forget which LLM that they used for this. But basically what they did was they changed the location of the Eiffel Tower from Paris to Lyon. And it only took 250 documents to do that. It's crazy, right? So the thing is, like, the thing is, the more research that we're doing and the more that we're looking into this stuff, everything is, it's like doing SEO in 2002 at the moment. It's really, really wonky. So, and what's really interesting about this study is it doesn't matter whether the data set that they were using was 600 million or 2 billion, or like, doesn't matter how big the data set was, it still only took 250 documents. So it's an absolute amount. So even if you had like, 100 billion documents in there, apparently you only need 250, but it's which 250 are the ones that make the difference here. And so what we've been doing is reverse engineering this and figuring out where we place documents and how we place documents to make the manipulation, not to change the location of the Eiffel Tower, but to help our clients. Yeah? This is how you need to think. So we just did a massive data study. We've done 300,000 citations. We're trying to do 100,000 citations in the process. And this is just some of the results that we've got from that. And this is not all of the work that we've done. This is up until about 6 weeks ago. And we've got actually a lot of actually even cooler data than this to share. But just for this presentation, we'll keep it here. So before I get into that, I'm just going to quickly give you an overview on how AI search works. So there's the LLM crawlers will go out and they will just scrape pages on websites, just keep scraping. And they're actually quite efficient in their scraping. They're not actually taking all the content from a page. They're mainly taking the URL page title, the meta description, and then the chunks. So the specific things that are answering specific questions, and they're stripping out a lot of the other content. So if you're used to writing SEO content, at least 70% of the words on that page are completely redundant. It just strip it out of the model because it takes a lot of work to process that information and also to store it. So it's scraping. So and on the simplest level, if your page title, your URL, and your meta description is optimized for that specific kind of like target keyword prompt that you're trying to go after, that's already 80-20 because that's something that they take really easily. So they're scraping, then they're chunking the data in different ways, and each LLM has a different process for chunking. So ChatGPT will, when I say chunking, let's just say that you want to have an article on like how to win at blackjack. Maybe there's like step 1, step 2, and step 3, and they'll just take the headline mainly, and then the paragraph underneath it, and just the core words. They'll strip out the words like and, or, and all these kind of like irrelevant words, and just keep the very kind of like concentrated words. And that's kind of how they chunk. Yeah? And then what they do, they take those words and they tokenize them. And tokenization means they turn those words into numbers. When they turn those words into numbers, they're basically three-dimensional coordinates. So they're putting the words and then taking those words and putting them into a three-dimensional space, into a vector, right? And I think some of you have heard about vector databases and seen like pictures of clusters. This is how it all works. So it takes the words, turns them into numbers, puts them into three-dimensional space. So like the word like apple here, if it's next to the word banana, contextually it's a fruit. Now, if the word is apple here and it's next to Facebook, contextually it's a tech company. Does that kind of make sense? So the contextualization that the LLM is able to do and like understand how to speak English is by vectors and like multi-dimensions. This is the simple way, okay? I won't go into multi-dimensionality at this point in time, but basically it stores in three-dimensional space. Then what happens is you ask a question, and then let's just say it's the blackjack example. So you want to learn how to win at blackjack, right? And then what it does is it scoops up 100 different chunks of potential answers for how to win at blackjack. takes those 100 answers, figures out in a specific process on which is the most relevant answer and which answers correlate. Like where is there consistency across the answers, and then spits it out to you, in the app, yeah? And you can see the process happening. It's called inference, when it basically kind of like, it's processing. It's going, all right, which chunks am I going to take? Oh, okay, we've taken all the chunks now, and then we're going to resort the chunks out and find the right contextual answer for this user's needs. It's a different process to how Google works on some level. And sorry, I didn't mention, this process is called Retrieval Augmented Generation. This is the second phase. First phase is getting all the information, indexing the information inside the model. And the second phase is the RAG process, where it basically takes that information out and resorts it. So, we're all SEOs here. I'm going to break it down in the same process and methodology of how SEO works. Technical, content, backlinks, and then obviously tracking and reporting. With our research and the way that we're deploying this process, we're using the same framework, and we're finding that it actually makes a logical sense. Because when data scientists come at this problem, they have a different way of looking at things, and they're very like interscraping things, and they just see things differently than an SEO would see things. And there's advantages from the way a data scientist looks at things, and there's advantages from the way of looking at things from this context here. So we'll go through this process. So indexing. So this picture here is, I have this on my wall. And I have it on my wall for multiple reasons. Now, the beautiful thing about this picture, it's from Common Crawl, and Common Crawl is basically an open source repository of like information, foundational data that the LLMs use. How Common Crawl came about is the guy that sold AdSense to Google, I think it was in 2007, ended up creating a foundation to scrape the web as his gift to humanity after probably making a very, very large sum of money, right? Now, the really cool thing about this visualization here is this is everything on the web that can be scraped, squashed down into three-dimensional space. So everything in here, this is everything that's digitally encoded, right? This could be like, Greek philosophers over here, World War II here, Britney Spears here. This is everything just like encoded from the web, squashed down into three-dimensional vector space. And for me, it's fucking beautiful. Like it just has it's like music, and there's just something magical in it. And so yeah, I have this on my wall because it is that, and it's also like, how do I take all that information in and dissect it and find the patterns inside that amount of data? So the LLMs have access to Common Crawl, and anyone can access Common Crawl, by the way. You can just download it. It's massive files. I'm good friends with the people that run Common Crawl now. And this is what the LLMs use as their kind of seed data set, and it gets updated every month. So the thing here is, if you can get your client, your site or your client's site into Common Crawl, you're winning the race, is the simple way to say this. So, how to check if a site is in Common Crawl? You can actually quite easily just put a URL in and just see. Now, with Common Crawl, you won't have a whole site, because we've been talking with them, and I had a meeting with them, and I was like, kind of figure if I could be like a friends of Common Crawl and like be a benefactor of the foundation to see if I could do my own manual seeding. They said no, but I tried. But we had other reasons to call them. But basically, you can just check it in, and also if you are working with clients, there's an API there that you can just like ping, because we just do so many API requests to these guys, so we had to kind of talk to them and optimize our process. But yeah, you can check whether or not your site or your client sites are in Common Crawl. Now, other data sets, this one's called the pile. And this one includes a whole bunch of different things. Like you've got like, GitHub over there, archive, or however you spell that. Like Gutenberg is basically Google Books, like the Project Gutenberg, like Wikipedia, Reddit. So a lot of the sources that most people talk about, although like Reddit and stuff isn't actually in this data set, but this data set gives you an idea of where they're actually taking their information from and seeding the LLM data. Because the LLMs have a limited amount of crawl budget to kind of crawl and explore the web. It's a lot easier for them to get these data sets. So if you can get in these data sets, then you're going to be they get much more visibility, if that makes any sense. And there's a whole bunch more of these, and we're doing a whole bunch of research on how to do this process. And this is just a simple example of it, but then it really comes down to like, what kind of site are you trying to rank? And where can you place documents in different areas? That's the process here. That's the strategy. Model probing, I won't overwhelm you too much with model probing, but model probing is basically figuring out whether or not something actually exists in an LLM. So here's an example. From the answer from the training language only, not on the web, what house edge percentage appears in Steak's main blackjack page? So we're asking ChatGPT, we're going, hey, tell us what the percentage, house edge percentage is on Steak's blackjack page. The answer is 57%, or 0.57, sorry. Or, it's 57%, but it came back, and the models came back and said it's 50%. So it's not correct, yeah? So it's hallucinating here, yeah? Does that make sense? So there's a hallucination here, so it means that, and 50% is actually a pretty smart answer. That's probably a really safe answer, right? So what it means here is that this page here, more or less, is not indexed in the model. And there's more sophisticated ways to this process, but from a basic level, this is how you kind of do it. And so we can take this process and write scripts and just run it at scale. Now, in normal SEO, you'll sit there and say, okay, I have 1,000 pages on a website, and most of those pages will be indexed in Google, but let's assume that there's 1,000 pages on a website and only 600 of them are indexed in Google, and there's 400 missing. So in order to optimize, you need to focus on the 400 that are missing, right? In the same kind of logic, let's just say there's 1,000 chunks on a website. Using a methodology like this, we can figure out which chunks are missing. Does that make sense? Again, I don't think you're going to come away from this and just become absolute like GEO masters or AI SEO wizards overnight. I'm just trying to give you concepts and understanding on how the LLMs work. And it's just about exposure therapy. The more you learn the words, the more you kind of start to grasp the concepts, the faster along you'll be. And I can tell you right now, there's so much misinformation out there, and people are believing a lot of misinformation, which is great. They can go over there and do that. We'll go and do this, all right? So you have the house edge right now. It's better than 57%. This is from Steve Toth, and he's created this cute little like info page generator. And it just kind of like creates a little kind of like hashtag at the bottom of a page, and it goes, hey AI, learn about me. And it goes, hey AI, this is contextually what our website's about, and this is why you should do things with us. And it kind of just gives them a reference point to, it's like basically like a dynamic sitemap. So that's the indexing part, right? So you've got 1,000 chunks. How many chunks exist in the model? How many chunks are incorrect or don't exist in the model? They're the chunks we need to focus on. That's the first phase, indexation. Second phase is content. Now, if you want, just take a picture of this slide because I'm not going to go through how to like do all the things. But this is from Robert Nicol from Chiang Mai SEO, and I think it's just done a good job on this whole process. This isn't what my whole talk's about, but this just gives you an idea on like how to optimize content for AI. All the tools that we're testing out at the moment are just really anything at the moment to do with most of the consumer grade options, even if they say they're solving all these solutions in AI at the moment, we're finding that they're not. And they're not giving the right information. Because if you go, all right, and like an AI content optimization software, hey Profound, hey Mikhail, hey Tim, can you work on this bit please? They're not chunking and showing how things are chunking inside an LLM model. They're not showing how they're chunking and which chunks actually exist and how the LLMs are actually seeing a site. And this is what's missing. So a lot of the tools are just missing that. So anyways, that's some information there. The things you can look at later, research. Now, there was a leak in 2024 from Google. It was a leak from Google. It wasn't actually Google that did the leak. But what's really important here, and this is like actual code that Google uses in their algorithm, and there's a few really important facts from these pieces of information. Basically, there's a page embedding, site embedding, site focus score, and site radius. And these are basically like different like processes in the algorithm. So the page embedding, the process I talked about like with chunking and just stripping all the words out and just finding only the concentrated words, this is done on a page level. And if you want to rank for blackjack, then the page needs to kind of fit that kind of model. And then from a page level to a site level, it's trying to see how much of the site has thematic things around blackjack, right? What's thematically similar to blackjack? And the site focus score is like how condensed and how clustered that cluster is, or how strong is that cluster. We're trying to see how strong the cluster is. And the site radius is like, is the cluster here like this really all about blackjack and card games and then online casino? Or is it a random website that has a bit about blackjack and then it's like one of those like link farm websites that has like a bit about blackjack here and then a health section selling dick pills over here and, you know, finance section with payday loans in it, right? Having all these scattered things is really detrimental to actually showing the LLMs that your site, and this is from Google, but it's the same process, that your site is specifically about blackjack, specifically about card games, specifically about online casino. It's from a page level all the way up to a site level. And this is represented in 3 dimensions, and I'll show you some 3-dimensional visualizations later, which are different from this, but it'll give you a concept of what that looks like. Actually, I'll just pull it up now, it's a bit easier. Because it's actually just important that you understand the concept. So this will be an example of like clusters and visualizations, yeah? So this is actually a little bit too clustered and too visual, but you can kind of understand in 3-dimensional space how things are relational in a way. Different ways to do that. You know, and a cluster might be like a page or a set of pages, or it can be a whole site. So what you want to be able to do is replicate what the LLMs are doing. You want to be able to scrape your website or your client's website, extract out the thematic keywords, then you want to like embed them in 3-dimensional space, in that 3-dimensional space, and then you can see how different pages are kind of related and which ones are not related. And then you can kind of tweak it from there and then visualize it or prune it. So you can see if you have a cluster that's like there's a bit of a cluster here and a bit of a cluster there, and then there's all these kind of scattered things over here, you might want to remove all the scattered pages and try to bring everything into one supercluster. And if you do that really well, then that's just giving the purest signal to Google. Now, this is an example from Common Room. I forgot where the actual original piece came from, but basically, they've done this really well, and they did it very, very quickly in like less than a month. So a month ago, this is what it asked LLM what the software was about. It was GTM intelligent platform rooted in community, and that's That's what the AI was kind of like saying it was. And then after they did this process of just cleaning everything up, it's an AI-powered GTM platform focused on pipeline generation, right? And the primary use case is, this is like not good, understand and act on user behavior because that doesn't make any sense. Capture buying signals and automate outbound players of AI, right? So you can take how an LLM sees you like this and give a really targeted answer. Because when an LLM's looking at you, let's just say that you've got a B2B SaaS, right? And you've got all these kind of fluffy words that don't really mean anything. And let's just say you've got a CRM SaaS, right? And you're asking LM to compare the best CRM SaaSes for you. If you have a lot of fluffy words that don't mean anything, you're not really going to show up. Whereas if you really refine the process and really say, hey, we are the SaaS we are the AI-powered GTM platform focused on pipeline generation. When people go, what's the best platform for pipeline generation? It's going to go, that's the answer. Yeah, and it gets a little dopamine hit, and then the user gets a dopamine hit, and then you make money. That's how it works, right? Target buyer, like these are random things, but really it's revenue leaders, head of sales, marketing ops, right? You can actually show the LLMs what you want, right? And this is where it makes a massive difference. And if you can pull this off, significant revenue. Because again, it comes back to that thing of like, all of a sudden, you optimize like this, and it's like all of a sudden, you won't make much money, and there's all these like sales coming in from like ChatGPT or like just branded search that are just, because those users that are actually typing into ChatGPT, they just trust, I was in Thailand like about a month ago, and I decided who's the best tailor in Thailand or in Bangkok or something. I want to buy a suit, and they just went, this is the best one. I went, cool, and I just called them. And then I bought a suit, right? And I think a lot of you are doing the same thing. Was it the best? It was actually pretty good. It's a little bit too thick. It was purple velvet, and I had and I've got like on the inside I've got like galaxy kind of like silk. Yeah, it's like bam. Yeah. I know it's too. I'm already sweating. All right, so this is Kufore by Mike King. Hey, Mike. I want to speak at your conference. Just suck up. So what's really interesting here is I put in the keyword, this is Kufore, this is his tool, and there's actually a couple of things I want to show you just to kind of help you think differently about how to process this. I typed in the prompt, how to build a rocket, and it's come back with a whole bunch of like different queries that it thinks that I should have in there. Now, what's interesting about the different queries is it's figuring out what type of query it is. If it's a personalized query, it's like an easy rocket building for kids. If it's what materials needed to build a model rocket, it's a very implicit query, right? And the basic principles of rocket propulsion is a related query to how to build a rocket. And so, see, Google is just kind of retrieving on like one level. This is much more granular and much more sophisticated in the way it's retrieving information. And this is what I want to show you, right? And it's showing you here the user intent for like the personalized one for the kids project, build projects for kids. The user intent is building a simplified, safe, age-appropriate rocket building activity, right? Whereas implicit is like wants to know the components and supplies required for starting the project. And so it's showing you how the LLMs are thinking, right? Because if you can start to think like an LLM, you're going to be able to like slot into what they're doing, if that makes any sense. Again, I don't expect you to understand all these concepts today. It's more about just undertaking little bits and pieces that you're going to be like, this is how it thinks. So next time you're chatting with ChatGPT, you're going to be like, okay, I kind of see what it's doing now. And the more awareness you have, the more you're going to see how it all works. This is really cool. This is by Robert Neokal as well, and he actually has the Python script down there as well. I really recommend running the Python script because you learn a lot in actually running the Python script. It's got a lot of information in there. So basically, I put in the keyword rocket and got a whole bunch of queries out of this tool, which is from Gemini, right? And whether this is for Gemini, it's normally for AI overviews and possibly for AI mode as well. Like it's all kind of the same kind of thing in the Google ecosystem. And it basically figured out what are the best queries for the keyword term rocket. It's figuring out, like, let's say, how to build a rocket. There's a whole bunch of queries that I got out of it. And what it's doing is it's basically showing you in three-dimensional space for the keyword term rocket or the prompt term rocket, what the best queries are that are relationally close in that kind of cluster level. So when I'm talking about clustering and these kinds of things, the word that we're using is cosine similarity, which is what I was explaining before on some level about how Apple is to fruit and Apple is to tech company, right? Cosine similarity is actually the angle, like how far things are related. So Apple is very close to banana, but it's very far from F100 pickup truck, right? Does that make sense? Yeah, so the smaller the cosine similarity, the tighter the cluster, everything is relational, and that's what we're going for here. So if you run the script, you'll just get a lot more information on the process, on how this works. Because the really cool thing about a lot of the LLM stuff is a lot of the research papers actually share a lot of, Google's algorithm is like hidden behind patents and all these things, but a lot of the research papers, you can find a lot of open information where the people that were building the LLMs actually figured things out, and it's actually a lot more open. Perplexity doesn't hide fan-out queries, so how to build a rocket, and in Perplexity you're going to see it actually just shows you all the other queries that are relationally. So from a cosine similarity perspective, that's the most relatable, the closest cosine similarity, then a little bit further away, a bit further away, further away, further away. Cool? So if you are like trying to figure out, you know, what kind of queries you need to kind of write answers for your clients, you'd probably put the keywords that people would be searching for, and you get more answers here on like, oh cool, I need to create content around this, I need to create content around that. So again, like, this is really cool where with ChatGPT, like they kind of give away a lot of information in the source code. And so I was explaining there's like a foundational model. And then after you type in, like you want to, you know, run how to play blackjack as an example, out of the foundational model, it pulls out 100 different chunks. And then it takes those 100 different chunks and then it re-ranks them. It's called re-ranking. So it takes 100 different chunks and figures out of those 100 different chunks, which ones are the most important and relevant for that user's query intent, right? Like, you know, which kind of intent is it? Is it a personalized thing? Is it implicit? And as we go back here, you'll end up with, these are the chunks. Let's go. So these are the chunks, right? So these are the chunks, right? It's quite short. And these are the AI citations. These is where it's referencing those specific chunks from, right? So in that re-ranking process, where it finds those specific like chunks, it goes, oh, these 3 chunks are, you know, the same information, it's valid information, we're going to put it here and reference it from there. It uses a couple of different variables. One of the variables it uses is how fresh the content is, which is really, really scary because Google is based on the PageRank algorithm and authority content. And like, if you, what's happening here, and I'll show you the research behind it, it's saying if you have 2 identical documents, and one document is 5 years old, and one document is 1 week old, ChatGPT will rank the 1-week-old document over the 5-year-old document, which is super scary. Yeah. And it doesn't matter whether it's a news-related question. You could be like, what color is the sky, or why is the sky blue? It will rank the 1-week-old piece of content over the authoritative content that's been around for a long time, which is really, really weird. And so there's a lot of junk noise in these models. It doesn't make any sense. That's one part of it. The next part of it is in query intent, which comes back to that slide I gave you a few times ago, whether it's implicit, personalized. It's basically trying to figure out contextually what you're asking the model. And another part of it is vocabulary search is talking about, like, is the information like industry specific? It's like how sophisticated is that information? And these are just some things that are openly found out about ChatGPT. Now, to bring it back to when I said it pulls out 100 chunks, the top 40 are always newer than the old ones. And yeah, single pages can jump. Basically, the short version here is, so everything that's top 40 in those chunks, those top 40 chunks, are new, and everything that's 61 to 100 is old, which doesn't make any sense. Why would you preference new content over old content? Of course, in some specific prompts, I understand. But the point here is, a really simple thing to do is to update content, have the date on it, and just keep updating the content and just refreshing. There's like specific plugins you can do that kind of stuff. So having the date on your content, create fresh content, update it if you need to, and yeah, like, it's just doesn't make any sense. Again, like, the more research we've done into ChatGPT, the more we're just like, this is so bad, especially being around so long. We actually turned this into a tool, just an internal tool that we basically figured out. We've taken Robert's work and just kind of just turned it into a UI. So let's just say you do update your content, then you want to basically let the LLMs know that your content has been updated, and a way to do that is something called Index Now. So you can basically spam the hell out of Index Now, which is what a lot of people are doing these days. I've been doing it for a long time, actually. So if you update content, you ping Index Now, and you say, this is because the LLMs are going to go, all right, where should we crawl now? Like, where do we need to crawl? What's different? And they're going to go to Index Now and go, cool, there's a whole bunch of URLs that have been updated. Let's go figure out what's new. Yeah, so update content. It's like submitting the page into Google Search Console or something like that from an SEO perspective. Now, backlinks. This is my specialty from an SEO perspective, but now specializing this from an AI citation or from a LLM perspective. Now, so the data study, it's a whole bunch of words on a page, but the data study, we basically took a whole bunch of citations. So I think we're at 300,000. We're definitely probably close to 1 million now. Just haven't talked to data science team about it. But we basically got a whole bunch of citations from like 20 different industries and a whole bunch of prompts, and to create like 100,000 prompts, it's actually quite complicated to pull this off. But we scraped a whole bunch of data, and these are the findings. So the same thing that we did with our machine learning algorithm with backlinks, like you can give my team any data set and we'll be able to find the patterns in the data. So like someone said to us, Rich was saying, oh, what about, Rich was asking about, does, ads in ChatGPT going to affect how it all works? And I'm like, oh, well, once it's released, we'll just scrape the data and figure out what the patterns are. Maybe. Actually go at the back if you can, Mark, because I'm recording. So basically figuring out like when there's, it's all good, you can't see that, you can't see it there. So when you're, if there's a change made within LLM, whether there's a change made within Google's algorithm or within a specific LLM, then we just do a data pull and then we see what's different. And then when we see the difference, we can go before the algorithm update or the update from the data set that we have to the new data set. We're able to figure out what the different patterns are. And when we can look at the patterns, we identify the different patterns and we go, okay, there's something interesting to look at here. And so we start looking in that area. And that area might be the cosine similarity between like the page title to the citation. There's different patterns that we see. And then we look at those patterns and figure out why those things are happening and where we need to investigate further. So in this situation here, what we figured out was that the cosine similarity, which is that process of being really closely clustered. So let's say the prompt is around how to rank it, how to win at blackjack. To the page title, the cosine similarity, the actual amount of like angle between the term and the actual page title needs to be between 0.4 and 0.6. Because if you over-optimize and put too many keywords in there and stuff it, it actually doesn't work. But if you don't have enough keywords in there, it doesn't work either. So we can sit there and say, we can look at a page title. Let's say there's a page that wants to rank for a prompt around how to win at blackjack. We can analyze the cosine similarity for the prompt to the page and say, oh, it's about 0.2. We need to do a bit more work and put a bit more content onto the page title to make the cosine similarity hit 0.4 to 0.6 to hit that sweet spot. So we're just able to see the patterns that the LLMs are actually showing us, right? They're like, oh, this is what we think is the sweet spot, So the same thing here happens with the actual content for the page as well. And content is different to theme, but we can see here that most things fall between 0.3 and 0.5. So if we do cosine similarity analysis on the content and that it's above 0.5 or below, forget this spike, that's unrendered JavaScript, then we know this is in the sweet spot. So we can reverse engineer the LLMs, is pretty much what we're doing here. This one is the same thing, page topic. This is like extracting of the themes of a page out. And you can see it's very, very sharp in that 0.6 to 0.8 range. So if you're not in that range, it's not a positive correlation, so you're not going to rank. And these things change over time too, by the way. Like with Google's algorithm, it does. Yeah, fine. So we actually built out a tool that does that as well. So we can upload content and then just figure out where the sweet spot is. We can modify things so it's not, the color's a bit off, but we can modify things and figure out whether the page or the batch of pages or content is all within the sweet spot and what it needs to be modified to hit that sweet spot. And harmonic centrality, this is a new thing as well that we've been learning about. And this is it's called a link graph, and it's basically like how social media works, and I'll get into that in a second. But how like you might have an influencer that's in the center of a node, and then you have all these spokes off it. So harmonic centrality is the actual math behind how social media engines work. I'll show you a bit more of that in a second. Oh damn, we can't show you this. Oh, it's blown out. All right. This is the magic that we found, the main thing that's incredibly valuable for our clients. Now, on the left-hand side here is a whole bunch of prompts. Let's just say how to rank at blackjack, et cetera, et cetera. And on the right-hand side over here is all the pages that are actually being cited in ChatGPT. You can't see it, but there's actually like a lot of clustering. So there's like there's a line going from here to there, and there's like, you can see a real definitive pattern in how the data is kind of skewed towards specific pages. And you can't see it there, but I'll should be able to find something. The presentations will be, okay. So what we discovered in this process here is something called co-citation similarity. It's different to cosine similarity, it's called co-citation similarity. Now, this actually comes from like academic research papers. And so when you're citing things with academic research, if multiple authors, you can imagine that there's actually a whole bunch of lines going to these three here. That one's going just over here, and that one's going just over here. Actually, no. But they're all kind of going, these ones here are going into this section here. If multiple authors are citing the same references or the same articles or content, then that is a co-citation network. And for some reason, the LLMs are using co-citation similarity to rank high important pieces, what they are deeming high important pieces of content. So what's interesting here is in this example that I can't really show you the visualization of, we ended up putting a whole bunch of prompts on how to play blackjack, and we pulled out 3,000 citations. And out of those 3,000 citations, 126 were repeated again and again and again in the prompts. And going back to the start, when I got you to pull out your phone and do ask the question ChatGPT, this is what's happening. Basically, all of these ones here are the same as the Four Seasons and Ritz-Carlton. So for any prompts or that we're doing, we can identify which sites are being shown across all those terms. So if you type any kind of prompts around, best hotels in Hawaii, then you're always going to get pretty consistently, Ritz-Carlton Four Seasons across all the terms. Now, whether that's you're doing best hotels Hawaii or if you're doing how to play blackjack, we've figured out which ones are the ones that are showing up all the time. Yeah? So out of 3,000, we've got 126 that are really, really important to the LLMs, and the other ones are kind of junk. And yeah, this is kind of like the harmonic centrality is that kind of social media, kind of influencer kind of thing, but this is like papers, not humans. So it's another visualization. And more clusters, different ways to visualize things. So what we found, so there was like 3,000 citations, in this example, there's 3,000 citations and 126 were the good ones. Now, what we learned was those 126 show up consistently. The other 3,000, in this example here, we've done this across many data sets, but most citations will show up once and never showing up again, pretty much, or very, very likely to be replicated. And that's all that you need to understand about this is basically, this is really, really good, and all this is junk that will never come back again. And coming back to that thing about how there's that recency bias with ChatGPT, it's not a matter of kind of finding those 3,000 citations and then going and trying to get links from all of those citations, because most of those citations will never show up again. But if you're strategic and you understand the patterns that are going on, then if you get links if you get cited on these pages and you go out to these website pages and go, hey, can I have a link from you guys? Then you're going to get traffic from the LLMs, and the LLMs are going to index and crawl this a lot more, because this is kind of like high authority citations. And if you're in this section here, then you're in the index, there's a higher chance of you showing up in the re-ranking process as well. So this is the work that we're doing, and these are the studies, and this is the results that we've got. Yes. So another little piece to add to add another layer on top of that is everyone's talking about listicles. Listicles is like the things to get in. If you want to rank in AI, you do listicles. And no one knows why you need to do listicles, but it follows the same process. So a listicle is like an article that has like, say you have like best online casinos, and you might have like 10 different casinos that are listed out, right? That's what a listicle is. Now, why do those listicle, whether it's, best online casinos or, which air fryer to buy as an example, right? So why is this so important? Why is AI loving listicles? Because everyone's going and creating listicles right now. It's the new thing. Oh, you can't see the bloody things. You can imagine that there's a whole bunch of like should be a whole bunch of lines there. Woo! Imagine there's lines. Now, these are all the documents. So these are all the listicles. And let's just say that these are the top 10 casinos. And if all the documents are linking to the same casinos, as an example, then the AI is basically going, all right, there's a pattern here. There's a pattern here that we can see, and it's correlating across everything. And so what we figured out what to do is basically we kind of hijack the citation. So if we see there's a listicle, if they're all linking to these specific things, and we can see the pattern, which I showed you before, like this, we can see that pattern, then basically we create a whole bunch of documents on different websites and attach ourselves to this cluster here. And if we attach ourselves to this cluster here, then it's basically showing the LLMs that this is attached to that cluster and this is important. I understand this is quite high level for most of you. In saying that, it's a thing of beauty. Yeah, that's what we discovered. Yeah, so we know a whole bunch of stuff. Now, the other cool thing that we've done is, so an AI citation is basically a web page, right? This is done for a friend of mine who runs a SEO software called Agency Assassin. And so these are web pages like searchenginejournal.com, like there's a whole bunch of website pages, all to do with SEO, backlinko.com. Now, these are the website pages. All of these website pages here are in that cluster. They all have that, they're all in that kind of node network. They have a high co-citation score, right? This is like a threshold that we've got there, and they're all in that cluster. We're also checking or not whether these pages are indexed in Common Crawl, because if they're indexed in Common Crawl, then there's a very good chance that the crawler will come to basically they're going to come to this page, or high probability they'll be indexed in the LLMs. Then what we've done is we've also checked out whether these pages are also ranking in Google. We've enriched the data with Google data. So not only are you able to get LLM traffic from getting placements on these articles here, but you're also able to get Google traffic because it's ranking for a whole bunch of keyword terms. So you're getting two different traffic sources for the price of one. And you've got a high probability of ranking in the LLMs. So this is like a new novel concept on how to basically do backlinking or AI citation process. Now, I'll just wrap it up. So tracking. Basically, the LLMs at the moment are spamming the hell out of so many sites, and a lot of companies right now are blocking all robots from actually going onto websites because they're just getting overwhelmed by all the LLM bots. And so what's important here is to understand which LLM bots are coming to your website and how often they're coming. Because if there's an increase in LLM bot activity to your website, it means that you're probably being indexed, right? So for your developers, whoever's actually managing or doing all the kind of like log file analysis, you can actually get a list of all the crawlers and bots that are up, that's been updated since April 25, because it's important to know which LLMs are coming to your website. And if if you're getting an increase in bot activity, it means you're probably being indexed in the LLMs. This is really cool, even though you can't read it. And this is by Profound. And what they've done here is, I can't even read it myself from here. Basically, there's different ways to check whether or not you're actually in ChatGPT. And a lot of the softwares, some of the softwares actually just do an API call. And if they do an API call straight to ChatGPT, then ChatGPT knows it's a robot making that request, not a human. So it's not going to spend resources on actually giving a really high quality answer because it knows it's a robot, right? And then the next level after that is called web scraping. And it means that there's a logged in version of ChatGPT that they're actually asking prompts to, and then it's seeing whether or not your client or your website is being indexed and actually being retrieved, and how much visibility in the actual LLMs there is. That's the next level. Now, Profound have done another level. They basically sat there and went within like an open version of ChatGPT. They've gone, hey, we are a company that's looking to purchase a CRM because I'm a marketing manager, et cetera, et cetera, et cetera. So it's giving it this personalization process. So when it's actually asking the prompt the question, that the answer is kind of personalized and relational, if that makes any sense. Because if it's logged in as a generic user for ChatGPT, it's not the same as my specific answers that when I'm running ChatGPT, because ChatGPT knows who I am. Cool. That's actually a really cool feature, and is the realest thing that you can get to actually understand whether or not your content is being shown on ChatGPT. And this is kind of showing like a product leader, a marketing leader, and a digital leader. So like different visibility for different things, which means that like the product leader has a lot of visibility. So the LLMs are preferencing for product leaders, the LLMs are preferencing that specific piece of content compared to digital leaders and marketing leaders. And this is why it's important, because if you have just a non-personalized ChatGPT account, it's not going to give you really personalized answers. Cool. This is something that we figured out, or Anthony did. Actually, Anthony's in a meeting with my team right now. But basically, when you're putting a prompt to track a prompt, if you just actually in the prompt area, just write what model of ChatGPT you're using, and it could be a hallucination as well, but it actually responds because you're actually asking ChatGPT a question. And we found that they were not actually doing web scraping, and they were actually using the API, which is a bit cheeky, but we're not 100% sure if that's true, but from what we can see, it is. Oh yeah, we've got a toolkit. We can talk about that later. And yeah, thank you for listening. I hope you enjoyed. Thanks,